All right, guys, back again today. All right, so we did some problems like this yesterday. I wanted to try a couple more just to make sure we're all on the same boat. Um, and definitely wanted to take some more because I know fractions are not always our strong point. Notice that all of these linear coefficients are all odd, so none of them are divisible by 2. Okay, so we're going to have to deal with some fractions here, which is okay. Okay, so let's start on that first one. Okay, so remember, I want to keep the quadratic term, x squared, and the linear term, 7x, okay, together. But I've got to figure out what constant term do I need there, okay, to create a perfect square. So I've got to take this constant term that I start with and just move it to the other side. Okay, so I would have a negative 12 over there. Okay, and whatever I add here, I have to add here. Okay, so let's see. Remember what we have to do here. We have to take the linear coefficient, we have to divide by 2, and then square that. Okay, so if I add that to the left-hand side, I have to add it to the right-hand side. Okay, so let's see what happens here. Okay, so I get x squared plus 7x plus, squaring the numerator and denominator gives me 49 fourths, okay, equals negative 12 plus, again, that would be 49 fourths. Okay, so I can factor the left-hand side into a square of a binomial, bring the sign of the linear term down, so that's plus. Square root of x squared is x. Square root of 49 fourths would be 7 halves. Okay, so we like that. All right, now we go to the other side, and again, I've got to add these two. Okay, so let's see, that would be like negative 12 over 1. Okay, so I'd have this negative 12 over 1 plus 49 fourths. So clearly I have to multiply above and below by 4 here so that they have the same denominator. So negative 12 times 4 is negative 48, and then obviously 4 times 1, okay, plus 49 fourths. So let's see, that will give me 1/4. Okay, so this is 1/4. Okay, so we get to this point, and I've got to take the square root of both sides. Okay, so I do that. And remember, anytime you take the square root of a number, a positive number, it has 2 of them, so we have plus and minus. Okay, so let's see, I get x plus 7 halves equals plus or minus, let's see, that's plus or minus the square root of 1/4. Now notice that 1/4 is a perfect square, okay, because 1 is a perfect square and 4 is a perfect square. So I can just take the square root of the numerator and denominator, and let's see, the square root of 1 is 1, the square root of 4 is 2. Okay. All right, so we get x equals, subtracting 7 halves from both sides, negative 7 halves plus or minus 1/2. And that'll give me my 2 solutions. Okay, so we have x equals negative 7 halves plus 1/2. And that will give me a negative 6 halves, which is just negative 3. Okay, so there's one solution. The other guy would be a negative 7 halves minus 1/2. And let's see, that'll give me a negative 8 halves, which is negative 4. And I get my second solution. Okay, so things worked out pretty good there. Not a big deal. All right, let's go to that second one down. Again, I want to keep that x squared and 9x together. I got to figure out, what's my constant term there. So we want to take this constant term we start with and move it and get it out of the way, move it over to the other side. Okay, so that would be a negative 18 on the other side, plus. All right, so let's see. I've got to take the linear coefficient, divide by 2, so that would be 9 over 2, and then square that. Okay, so that means I have to have 9 over 2 squared here. Okay, so I get x squared plus 9x plus squaring the numerator and denominator will give me 81 fourths equals negative 18 plus, again, I've already done that, I get 81 fourths. Okay, so we're good there. Okay, so let's see, we factor this guy. It factors into the square of a binomial. Bring the sign of the linear term down, so that's plus. Square root of x squared is x. Square root of 81 fourths is 9 halves. Equals, okay, this is like negative 18 over 1. So I've got to do my little sidebar, so it looks like I'm going to have to multiply above and below here by 4. Okay, so that would be a 4. 1 times 4 is 4. 4 times negative 18 would be a negative 72. Okay, plus 81 fourths. Okay, just doing this guy. Okay, so let's see. Negative 72 plus 1, that'd be 9. So I'd get 9 fourths. Okay. All right, so we're in good shape. So now we take the square root of both sides. And remember, anytime you take the square root of a positive number, you have 2 of them. So we get plus or minus. Okay, so let's see. This will give me x plus 9 halves equals plus or minus. And again, we luck out because 9 fourths is a perfect square. 9's a perfect square, 4 is a perfect square, so we take the square root, we get plus or minus 3 halves. So subtracting 9 halves from both sides gives me x equals negative 9 halves plus or minus 3 halves. And that'll take me to my 2 solutions. Okay, so let's see, we get x equals negative 9 halves plus 3 halves. That will give me a negative 6 halves, okay? And that'll give me a negative 3. Okay, so one of my solutions is negative 3. Okay, the other guy, I would have negative 9 halves minus 3 halves. So that will give me a negative 12 halves, which is negative 6. And I get my other solution. Okay, so we've got our 2 solutions there. Okay, let's go down to the next one. Okay. All right, so once again, we start it the same way. Keep the quadratic term x squared and keep the linear term negative 11x. I've got to figure out what do I need there to complete the square. Okay, so I want to get rid of that 30, so I move it over to the other side, it becomes negative 30 plus, okay. All right, so we take half the linear coefficient, so 11 over 2, and then square that. So we have to do the same thing here. Okay, we simplify. X squared minus 11x plus squaring the numerator and denominator will give me 121 over 4 equals negative 30 plus 121 over 4. Okay, I have to add these together, so that's like negative 30 over 1. So let's see, the common denominator would be 4, so I'd have to multiply above and below by 4. So when I do that, I get negative 120 over 4 plus 121 over 4, which obviously would give me 1/4. Okay, all right, so on the right-hand side, I have 1/4. Okay, if I factor this guy on the left-hand side, it's going to factor into the square of a binomial. Bring the sign of the linear term down. Square root of x squared is x. Square root of 121 over 4 is 11 halves. Okay. Take the square root of both sides. Again, anytime I take square root of a positive number, it has 2 of them, so that's plus or minus. Okay, so x minus 11 halves equals, once again, 1/4 is a perfect square. Square root of 1 is 1, square root of 4 is 2, so we get plus or minus 1/2. Okay, so adding 11 halves to both sides gives me 11 halves plus or minus 1/2, and that will take me to my 2 solutions. Okay, so I get x equals 11 halves plus 1/2. That will give me 12 halves, which is 6. So 6 is one of my solutions. And then the other guy, be x equals 11 halves minus 1/2. So that'll give me 10 halves, which is 5. Okay, and I got my other solution. Okay, good shape there. Okay, last one here. Again, I know we're just getting some more practice in here. Okay, so let's see. Last one. All right, 4. Okay, again, keep the quadratic term, keep the linear term together. Okay, take that constant term, move it over so it becomes -6. Okay, now we complete the square, so we take the 5, we divide by 2, and we square that. Okay, so if I add it to the left-hand side, I have to add it to the right-hand side. Okay, so this is x squared minus 5x plus 25/4, and that is my perfect square trinomial. On the other side, I know I'm going to have to add these guys, so that's like -6/1 plus 25/4. Okay, I can factor this perfect square trinomial into the square of a binomial. Okay, bring the sign down, so that's minus. Square root of x squared is x. Square root of 25/4 is 5/2. Okay, let's see here, I'm going to have to multiply this guy above and below by 4, so that'll give me a -24/4 plus 25/4, which gives me 1/4. Oh, isn't that nice? Again, we get another perfect square. Okay, taking the square root of both sides, and remember this will be plus or minus the square root of 1/4. Okay, so I get x minus 5/2 equals plus or minus. We already know, we've seen this more than once already. So the square root of 1/4 is 1/2, so I get plus or minus 1/2. So adding 5/2 to both sides, I get 5/2 plus or minus 1/2, and that'll take us to our 2 solutions. Okay, so let's see, I would get x equals 5/2 plus 1/2, which gives me 6/2, and that obviously is 3. Okay, the other one would be 5/2 minus 1/2, which gives me 4/2, which obviously is 2. So I get my 2 solutions. Okay, so again, solving by completing the square should be something that you've seen before, or I know it's something you saw before. Okay, we just need to do a little bit of review on that. Okay, so one thing that we haven't touched on is what happens when you have something like this. Okay, where notice these guys are different than these guys, because notice all of these leading coefficients, the quadratic coefficient is 1 all the way down. Well, here they're not. Okay, so all we're trying to do is create a perfect square trinomial. Okay, and you can only do it if the leading coefficient is 1. That's the only way you can do it. Okay, all right, so what we have to do here is we have to factor out, okay, that leading coefficient. Okay, we got to start there. Okay, so if I take that 2x squared plus 10x plus whatever that's going to be to create a perfect square trinomial, okay, I've got to factor out this 2 first. Okay, so when I factor out the 2, I'm left with x squared plus 5x plus whatever that has to be right there. Okay? All right, so now that inside these parentheses, now that the leading coefficient is 1, I can use my same rule I've been doing. So we take the linear coefficient, we divide by 2, and we square that. Okay, so I get 2 times the quantity of x squared plus 5x plus squaring the 5/2 will give me 25/4. Okay, so let's see. I'm going to get 2 times this guy, which is a perfect square trinomial, x squared plus 5x plus 25/4. Okay, and this guy right here, this column right here will be my perfect square trinomial. okay? And then I want to factor that, okay? So I want to go to my factored form, which you'll have to do on the quiz, okay? All right, so I have that 2 out front. Every perfect square trinomial factors into the square of a binomial. Bring the sign of the linear term over, okay? The square root of x squared is x, and the square root of 25/4 is 5/2. Okay, so I've got my perfect square trinomial here, and I've got my factored form of my perfect square trinomial. Okay, let's do another one. Let's take that second one down. Okay, so I've got my 3x squared plus 12x plus, I don't know what that is. Again, I have to get rid of this leading coefficient, so I factor out the 3. And so I'm left with x squared plus 4x plus, now I can complete the square. Okay, so we take our linear coefficient, 4, we divide by 2, and then we square that. Okay, so I have the 3 out front, the GCF. I get x squared plus 4x plus, well, let's see, that would be 4 divided by 2, okay, which is 2, and 2 squared is 4. So there's my perfect square trinomial. Okay, so I have 3 times x squared plus 4x plus 4. That's my perfect square trinomial, and then I put it in factored form. So I've got that GCF out front. All perfect square trinomials factor into the square of a binomial. Bring the sign of the linear term over. Okay, the square root of the first term is x, and the square root of the third term is 2. And so I have the factored form of my perfect square trinomial. Okay, let's do another one. Okay, let's take this next one down. Okay, I have 2x squared minus 8x plus whatever that missing coefficient is. I'm sorry, missing constant. Okay, so factor out the leading coefficient. So I'm left with x squared minus 4x plus some missing term inside. Okay, so let's see, we take the linear coefficient, we divide by 2, and we square that. Okay, so I'm going to get 2 times the quantity of x squared minus 4x plus 4 divided by 2 is 2, 2 squared is 4. So notice how similar this guy is to the last one. Okay, really close. So let's see, my perfect square trinomial will be 2 times the quantity of x squared minus 4x plus 4. So there's my perfect square trinomial. And notice the only difference inside here, okay, is the linear term is negative as opposed to up here being positive. Obviously the GCFs are different out front. Okay, so if we put it in factored form, you have your GCF, which is 2. Okay, all perfect square trinomials factor into the square of a binomial. Okay, bring the sign of the linear term over. The square root of the first term is x. The square root of the last term is 2. Okay, we're good. Okay, got our factored form of the perfect square trinomial. Let's go down to the next one. Okay, so I have 4x squared minus 24x plus some unknown constant. Again, factor out the leading coefficient. So I'm left with x squared minus 6x plus some unknown constant. Okay, again, take the linear coefficient, divide by 2, and then square that. Okay, so I'm going to get 4 times the quantity of x squared minus 6x plus 6 divided by 2 is 3, 3 squared is 9. So I have my perfect square trinomial. Okay, so we have 4 times the quantity of x squared minus 6x plus 9. And that is my perfect square trinomial. Now we can put it in its factored form. So I have the GCF out front. Once again, all perfect square trinomials factor into a square of a binomial. Bring the sign of the linear term over. The square root of x squared is x, and the square root of 9 is 3. And we have our factored form. Okay, got 2 more left to do, and we'll call it a day. Okay, so let's see what happens here. Okay, I have my 3x squared plus 15x plus an unknown. I factor out the leading coefficient. So I'm left with x squared plus 5x plus an unknown. Okay, so I take the linear coefficient. I take half of that and I square it. Okay, so we have 3 times the quantity of x squared plus 5x plus, notice 5 is not divisible by 2, so we just leave it as a fraction. And so when I square 5 halves, I get 25 fourths. And that is my perfect square trinomial. 3 times the quantity of x squared plus 5x plus 25 fourths. Okay, then I factor it. Okay, 3's out front. All perfect square trinomials factor into the square of a binomial. Bring the sign of the linear term over. Square root of the first term is x. Square root of the third term. Now this is a perfect square, so you just take square root of the numerator and square root of the denominator. So I get 5 halves. And we're in good shape. Okay? Notice how similar this guy is to the top guy. Okay? Real similar. The only difference is the leading coefficient. Okay. All right, one more to do. Okay, we have 5x squared minus 30x plus some unknown. Factor out the leading coefficients. 5 goes out front, so we have x squared minus 6x plus some unknown. Okay, so let's see, we take the linear coefficient, we take half of that, and we square it. Okay, so we've got 5 times the quantity of x squared minus 6x plus, well, we luck out. 6 is divisible by 2. 6 divided by 2 is 3. 3 squared is 9. Okay, so we got our perfect square trinomial. So 5 times the quantity of x squared minus 6x plus 9. Okay, and let's see. So we have the 5 out front. All perfect square trinomials factor into the square of a binomial. Bring the sign of the linear term over. Square root of the first term is x. Square root of the last term is 3. And we've got our answer. Okay. All right, so pretty good for today. We got a couple more types of problems as far as completing the square we got to do tomorrow. Okay, so I'll have one more video tomorrow, and I will upload this week's quiz today. It'll be due next Monday, just like always. Okay, you guys stay safe, and I miss all of you.